Welcome to our online walkthrough of the Post-Process Kinematic PPK positioning workflow in True View EVO for the DJI Phantom 4 RTK. This walkthrough will take about 65 minutes in length as we go into some detail on the different steps in the data processing. Just want to start by talking a little bit about the Phantom 4 RTK. Obviously, many of you are probably familiar with it, probably already owners of this system. But if you're not familiar with it, just a little bit of background. This is DJI's, one of DJI's enterprise-level drone solutions for surveying. It's of great interest if you're interested in high accuracy mapping because of several factors. It has an integrated multi-frequency carrier phase GNSS receiver. This is ideal for what we want for doing this kind of aerial mapping. It does record an observation file, a GNSS observation file during the flight, which means that we can use that for PPK workflows. Unlike many of DJI's consumer drones, the camera is synchronized with the GNSS system, so it provides time-stamped exposures for the camera, for the images, essentially the mid-exposure pulse that we're always looking to have when we're doing mapping. It has a good, robust mechanical shutter. A camera calibration is provided. We do find that the camera calibration that's provided by DJI from the factory is probably not robust enough for the kind of mapping that we want to do. So we do recommend getting a full camera calibration done. If you had purchased a P4-RTK system through GeoQ Group, that camera calibration would have been provided when you purchased the hardware. We also offer that as a service if you have a system that you purchase elsewhere, but you want to have a full calibration done. I'll come back to calibration a little bit in the workflow and when we get to that point and talk a little bit about how that gets used in the data processing. Finally, just as a note, the Phantom 4 RTK is a guest sensor in our True View EVO software. So obviously True View EVO is built around our True View sensors, our 3D imaging sensors, such as the True View 515 or the True View 640, which are integrated LiDAR camera payloads for doing drone mapping. But we do support several of DJI's sensors as guest sensors in our workflow. So if you see me talk to or refer to as a guest sensor, that's just referring to the fact we're doing the Phantom 4 RTK workflow within the True View EVO environment. Let's talk a little bit about positioning options that you have when you're flying your Phantom 4. Obviously, it's the Phantom 4 RTK, real-time kinematic. So that's a very common mode to operate in. If you're familiar with RTK, you understand how that works. You're either going to work with the DJI base station, the DRTK2, or you're going to work with a broadcast service to get your real-time kinematic corrections. And typically, you're going to be adding the USB cell modem to the Phantom controller, as it's the controller that maintains the real-time link with the drone during the flight. But essentially, you're going to go out, capture imagery using the RTK corrections to geotag those images with a more accurate position. And then you're going to flow those images directly into your photogrammetric software, Metashape, Pix4D, SimActive, something like that, to do your ortho photo generation. Now, PPK, post-process kinematic, is an option with the Phantom 4. This essentially means that we have to add an additional step in here, which of course is what we're going to look at in our walkthrough, and that's to do the post-process kinematic processing in True View EVO. So essentially tag the images with the PPK position information and then flow it into our photogrammetric software. And I'll show you at the end of the walkthrough how we've integrated tightly with Agisoft's Metashape and also Pix4D so that you can actually drive Metashape from directly within your True View EVO workflow. You don't have to be going in and out of different software packages, and that helps streamline the workflow. So before hopping into the software, let's just talk a little bit about the flow, about how your data files move through your processing stream as you come back from doing a flight. So obviously you've gone out, you've flown your project site, you've collected your data during your flight, you're going to land, you're going to transfer via the micro SD card all of the images and the support files, copy those over to your laptop or your workstation back in the office, and that's going to give you essentially your image data. Now, of course, for PPK, we want to have some base station information, so we're going to have some base station files that we're also going to copy over onto our laptop. And the way that we recommend structuring this, and as you'll see in the walkthrough, essentially we recommend creating a project folder and then just directly copying over your flights from your Phantom 4 into subfolders of your cycle folder. Cycle is a term we use within the True View EVO ecosystem, essentially meaning your flight or collection of data. So you can see here in this particular example, I've got we'll call them flight 19 and flight 20. And then in another subfolder, I've got my base station information. What does that actually look like on your drive? Of course, well, each of the flights is going to just look like it would look like on the micro SD card. So flight 19 here, I have all of my images, I have my log files. Most importantly, I have the two files that I'm going to need for my PPK processing, the observation file and the timestamp file. In my survey folder, I've got my base station data, just a standard set of files that you would have with doing any static base station observation. Primarily, I've got my observation file, which is going to be key. You'll also notice that the ATX file, if you're not familiar with that, that's an antenna calibration file, and I'll talk a little bit about this in the walkthrough as we get to that point. So you essentially want to have your data structured in this manner. So with that, let's hop over into True View EVO and go through the workflow. One point to mention just before I do that, True View EVO comes in several different license levels. To do the PPK processing that we're going to look at today, you actually simply need the Lite version, True View EVO Lite. So that it gives you a chance to save a little bit of dollars. You can buy just the Lite version and still get the full PPK functionality that I'm going to show you now. So the first step, of course, is to import our data. So I'm going to go up here onto the True View toolbar, which typically by default is up here, and I'm looking for this green download arrow, which is our True View import wizard. And I'm just going to go ahead and click that. So this will bring up our import wizard. We're going to walk through this. There's about 5 screens dialogues that we're going to go through here to basically set up the import of our data and then run that and quickly set up our project for us. Now this is the same import wizard that's used for any True View workflow. So obviously if you were using a True View 3DIS sensor, a LiDAR camera sensor, there would be a slightly different set of options that we would choose here because we are working with a guest sensor, the Phantom 4-RTK in this case. We're going to import the cycle from guest center. Just as a note, we do support several other DJI sensors as guest sensors within the True View EVO workflow, the M210-RTK and the DJI, the new P1 camera. And there's a separate walkthrough for the P1 workflow, although a lot of the steps that we're going to take here with the Phantom 4-RTK workflow are very similar. One of the advantages of keeping everything in a single seamless software. We just click next here. So we're going to import flights individually. And so we need to point to that high-level flight folder that we downloaded off the Phantom 4 SD card. So I'm just going to browse out here to my data drive. Go to that high-level folder, and in my raw cycle folder that I created, I've got these flights. So we'll start with flight 19. Go ahead and select that. The wizard will quickly check to make sure that we have a valid observation file and a valid timestamp file. So our .obs and our .mrk file, they're there in that folder. It'll also give us a little bit of metadata here in terms of the start time, end time, and duration of the flight, and total number of images that we have. So TrueView is going to create a TrueView project for us. There's some options as to how you want to structure this, of course. Essentially, what we need to tell the wizard is just what the root folder is where we're keeping our TrueView projects. And you can set that as a default in the software, so you'll always start in that root folder. Or, of course, you can just browse out and select a new root folder if you want. So I have a root folder where I'm keeping all my TrueView projects. And then I need to give a project name for this specific project. Typically, you'll come up with your own naming schemes, of course. I typically like to go with the date. This was collected in June last year. And some descriptor. This is an irrigation site. So that's what we'll use here. And it's going to create a subfolder in my root folder for this project. That's where it's going to store all of the TrueView EVO data sets or anything that we do within this project. So now I need to give it some cycle information. So cycle is a term we use within EVO to reference a flight, essentially. And we keep that consistently across all of the workflows, although some of the different sensors have different names for it. So in the Phantom 4-RTK workflow, there's no cycle per se on the GGI side, but we just keep that naming scheme for consistency across all of our workflows within TrueView EVO. So we have a cycle. That cycle is typically based on the date, which is fine. We now need to, I could change if I want to, but typically I'm not going to. We now also have to decide on our positioning strategy. So one of the advantages of working with TrueView EVO with your RTK data is that you're going to do a PPK correction. Of course, that's the big part of what we want to do. So typically we're running that with a local base station. That's the most common option that we're going to use right here. You're going to have a local base station, so we're going to bring in that information and do our post-process kinematic correction due to the trajectory. But because we're within the EVO ecosystem, we do have a couple of other options. If we didn't have a local base station or if there were some issues with it, we do have access to Trimble Planix's SmartBase, which is a virtual reference system, virtual reference station solution, or Trimble's global positioning solution, their PP4-RTK solution. Those are available through your EVO subscription. They're subscription-based services, but they work very well if you don't have a local base station. Local base station, of course, is the preferred option. I have a couple of options to add some descriptive text or to give an optional site name if I wanted to. Next, of course, I also want to set my spatial reference system. If I'm starting fresh or I'm just new using the software, I won't have any existing options, so I can come in here and I can select from an entire list of systems, including both ellipsoid and orthometric heights. For my vertical. If, as I have worked with this software before, I'll have a list of recently used systems here, and that's what I can use here. This particular one is UTM Zone 16 North, NAVD 88, Geoid 18. So I'll go ahead and select that. We need to tell the wizard where the base station observation files are. Obviously, the rover, the Phantom 4 obs file is in that flight folder, but we need to tell it where we put our local base station observation file. So I can just browse out to that. And you can see here that's actually in that field data raw folder, and there's my observation file. It's also important that we have an antenna calibration file. So I'm going to go say, yes, I do have an antenna calibration file. I'm going to go select that. That was also in my raw field data from my base station. We have a separate technical tip or note about how to get your calibration, your base antenna calibration file using the NOAA NDS antenna calibration website. You can find your antenna, and if you're using any sort of mainstream widely available antenna, you're going to have be able to get that file from there. So we have a separate technical note that'll walk you through that. It's a very straightforward process. My antenna height generally is going to be 2 meters. I want to make sure that's set correctly, though, if it's not. And I could add some ancillary files if I wanted to. For instance, if I had I'd taken a photo of the base station setup and I wanted to log that in here, I could do that as well. Now, of course, that local base station is going to be set up over a known point, a survey nail, if you will, and we need to tell the wizard what that location is. Now, again, similar to the coordinate systems, if I've been working with the software a while, I'm going to have a catalog of survey nails, known points that I'm using, because often I'm going to be going back to the same site and using the same point. If I don't, we can just open the survey nail manager, which is these two crossed nails here. And I can create and add the position of my survey nails in here. I can import and export these if I want to, if I need to exchange them with colleagues or so forth. I can just add new survey nails if I need to when I've got that information. Now, of course, if you're working in the US or if you're working with Opus or similar sort of systems, you may have that available from Opus. And if you have an Opus report, we can actually just go in and read in that Opus report. Here's my Opus report. Newmarket was where I actually had this base station set up, so I can go in and open that. And it'll go in, it'll grab the lat long elevation, frame of reference, and so forth. Now, if I don't have an Opus report, I can just enter these manually, of course, and I can give it a name here. And that will add that to this catalog of survey nails that I have. And I've already got most of my points set up in here. And so the one that I want is this Newmarket Madison irrigation site. So I'll say, okay, go ahead. That's my reference point. That's my survey nail for this particular project. Again, I could give it an optional description if I wanted to. And at this point, we can go ahead and finish. So the wizard had all the information it needs now to import the source data, so our images and our rover and base station observation files, antenna calibration information, so forth. And it's going to set up that project for us in that root folder as I talked about. So I can go ahead and import this, and we'll see some status running. You can see it's copying over the files. I'm looking at the status bar down here. It's going to copy over the files, going to start copying over the images, and then when that finishes, it'll pop up a completion. So there we go. So we have our project set up, and we're ready to move on. So let's quickly take a look at what was actually set up for us. So obviously our main window, our map view, we've got a backdrop in here. That's just a Google hybrid WMS layer. And we can see the trajectory and photo centers essentially of our flight. Now, if you're new to the software, over here on the left, over here, this is our table of content. So a project in True View EVO is layer-based like a GIS or many mapping programs. So part of what the import wizard did as it pulled in those images was to create some layers in our map. So you can see that we have a photo layer. That's the green dots, which are essentially our photo centers or our exposure centers. A trajectory line, which is basically the real-time trajectory of the aircraft, and that's also some trajectory points in there, and then our backdrop. So these layers can be arranged and moved as with a lot of mapping software. If I wanted to, I can change the ordering of them, the Z ordering, and so forth. So now we have our project set up. We've got our images imported. We have our real-time, our RTK positions, but we want to go ahead and do our post-process kinematic solution. That is, we want to refine the positions to have the more accurate post-processed solution, post-process position and orientation tagged to the images before we drive that into our ortho photo creation, which we'll come to at the end of the workflow. So to do this, I'm going to go back to my True View toolbar, just up here, and you'll see a tool that's marked PP for post-processing. It's just to the right of a couple of drop downs here where I can select cycles and flights. This is very handy when I've got multiple cycles, multiple flights in a project. We just have the single flight right now. So we'll just look at this post-process button, PP, and we'll go ahead and click that to kick it off. So this will bring up our post-processing wizard. Now, this dialog may vary a little bit depending on the sensor that you're using, but you'll always be able to tell what workflow we're doing because we do on the title bar of the dialog tell you. So we're doing a Phantom 4 RTK PPK correction, so it knows that because it knows that's the guest sensor. It'll pre-populate this dialog with some of the information that it already has. For instance, it knows the cycle name here. It knows the raw observation file location from the rover. You can see that's the Rhinex file, the OBS file from Flight 19. We need to confirm the processing mode. That is, how are we going to do our positioning solution. We can choose single base when we have a local base station. And as I mentioned, you do have access to some subscription correction services, Trimble Planex's Smart Base or Trimble's P4-RTK service. We're going to focus on the single base solution here. And then I can also tell it where I want to process the data. This really only applies if you're going to use one of those subscription services, in which case it's a cloud-based processing. I could select over here to do cloud-based processing. I get a couple other options, and I can put in my Reckon account information. But we're going to do everything locally here. Just for simplicity, that's the most common solution. Now, when I do this, I do get some summary data that's listed down here, the serial number of my system, some of the start and end time information, and so forth. And if I was running with a subscription service, you know, how many points it's going to cost me to do this. So really, once I'm set up with that, I just move on to the next step in the dialog. Again, it will pre-populate with some of the information we've already given it during the import. So my base station observation file that I imported in there, my survey nail location. Again, I could change them here if I had made a mistake on the import. You're not locked in. You don't have to go back and re-import, but you know, typically 99 times out of 100, hopefully better than that, even you're getting these correct on the import. And it's pulling in that data that we've already set in terms of the base station location, elevation, and so forth, and the base station antenna calibration file. So assuming I don't want to change anything here, it's just a matter of clicking through to next. So the next page is the Evomeris Settings page. So this is where we're going to configure the software to download the precise or updated Evomeris files or alternative navigation files, as well as configure certain GNSS processing settings. Evo is always going to attempt to download the updated Evomeris files when you first transition to this page or whenever you change some of your settings. Now, of course, you do need an internet connection to do this, so I'll walk through some of these settings and explain what's going on this page. So our first option is the Evomeris mode. The first option, the most commonly used one, the recommended one, of course, is to download the updated Evomeris files, use them in your post-process solution. Now, this does require an internet connection, as I mentioned. You can also use the broadcast or alternative navigation files, the .xxn or .xxp files that you have from your base station. This, of course, it can be used when you don't have an internet connection. You just have access to your base station files. So that can be an option. The second section is really just a toggle to tell Evo whether we want to use all the available satellite constellations, which again is the recommended default, or sometimes there may be certain circumstances when you might want to just use the DPS satellites if you're getting some noise or issues with the overall quality of your solution and you have a good GPS solution. You may just want to limit to the GPS satellite. So you have that option to toggle here. Again, the recommended is always start by using all constellations and see the quality of the results you're getting with that setting. There's also a path or link to where the Evomeris files and alternate navigation files will be stored on your system. This is tied into the project folder that we set up when we first created the project. So you can browse out to check to make sure that those files are there. Finally, the last section at the end allows us to set the elevation mask and the signal to noise ratio mask, basically to screen out satellites which are, for example, low to the horizon that may be noisier or have interference and may be reducing the overall accuracy of our solution. The recommendation here is, again, go with the default 15 degrees for the elevation mask, 30 for the signal to noise ratio, and only come back and adjust these if you're having issues, which I'll talk about when we get to that step in looking at the accuracy of the solution. And there is a final option as well related to whether or not you want to convert the base observation file to Rhinex 3.0. This can have some uses in certain circumstances. Again, the user guide goes into a little bit more detail on this, but generally you're not going to need to use this option. So once you have these all set correctly, and in my case using the post-process download from the internet option, I obviously want to have an internet connection. Assuming I'm all good to go, then I can move on and click next. So we're ready to go ahead and do the PPK, the post-process kinematic solution. We've just got a little review page here with some of the metadata we've been seeing, time of flight, etc. If I was using one of the subscription services, it would tell me how many points would be charged to my account. And then a results section here at the bottom. But assuming I'm happy with everything, I can go ahead and submit this here. It'll get me just a check screen. Are you sure you want to go ahead and continue this? And I'll say, yes, that's fine. I want to do that. So what will happen is a command window will pop up, and we'll shortly see this start to run here. It's basically going through each epoch in our flight, that 17-minute flight, and doing the PPK solution. You will notice if you look at the command line, we'll see that the status line does have a quality value, a Q value, which we will talk about. So you can sort of see that you're wanting to look for Q1 here, of course, so we're getting good quality data. do not seem to be able to pause. Maybe it's because that's running. I don't know. This would definitely be something that wants... So there we go. So we've completed successfully. Output trajectory file, output pause file has been created in our project. And so we want to move on. Now, it's always recommended to review the results that we have gotten from the post-processed solution. So we can look at that as a plot of the quality, essentially the accuracy of each of the individual photo centers. And we can access that directly here. Or if we want to review it later, we can on the True View toolbar up in the upper left here, there is an ability to just bring back the plot back up. But we'll go ahead and check it now. So this plot window essentially gives us a top-down view of our trajectory. If we zoom this in, we can see that we're actually seeing the individual exposure centers, the individual photo centers, and they are color-coded based on the quality result of the positioning solution. If you look down here on the status bar at the bottom, it will tell you the percentage of photo centers that fall within each quality category. Now, of course, what we're looking for is 100% Q1. Q1 is the best result. It means we got a correct fixed solution, and typically we're going to have that position within 2 centimeters or better accuracy. So we're looking for green, of course, and ideally 100% green across our entire trajectory. There are, in this particular case, a few Q2 results. It may not show up well here on the webcast, but we have about 0.9% that were Q2 values. And you can see those, they're over here at the beginning of the flight line in the northwest corner here. So a Q2 result means we had a float solution. We're probably not at that 2 centimeter accuracy that we want. And you know, depending on the situation of where that's occurring in my flight, that may indicate that I want to go back and reprocess, probably by increasing my elevation mask. We had this set at 15 degrees. I might want to push that up to 20, cut out a little bit more of those satellites closer to my horizon, and perhaps increase the signal to noise. Again, just to reduce some of the weaker satellites that were in my constellation. Now, it may also be that this particular section of my flight is not that critical to my project area, and so I'm not going to go through and reprocess those. And just for the sake of time, that's what I'm going to do here. But obviously, if you were wanting to have the best optimum solution, I'd go through and I would attempt to make sure I had 100% Q1. Now, you can occasionally get a red quality tag, a Q5 result, which essentially means that there's data missing. And of course, that's a more serious issue that you're going to have to troubleshoot. But let's take it as, you know, these results look good for this flight. I'm solidly green Q1 in all the areas I'm interested in, so I'm going to move on in my workflow. So I'm going to go ahead and dismiss our post-processing wizard dialog. We're finished with that for this flight. So I've created now a single trajectory file with the corrected positioning solution, the corrected PPK positions for the entire flight. Now, not all of this flight may be of interest to me for actually generating my products, my orthophoto and my point cloud. I may want to trim that out. I may not want to include my transition legs. There may be other aspects of the flight plan where I just have sections of the flight that I don't want to include. So what we're going to do next, the next step, is to create our flight lines and what we call True View trajectories. And these are essentially just a way to tell the software what sections of the flight we want to focus on when we come to generate our ortho photo and our point cloud. So it's just a way to refine down or filter down our trajectory points to those that we really want to work with. Now we can do this following along on our True View toolbar. So we just finished the post-processing, the PPK solution from the PP tool. We're now going to use the Create Flight Lines tool, which is the next button along. And I'm just going to go ahead and click that. So that will bring up the Auto Create Flight Lines dialog. This is a relatively simple tool. It is going to go through and look at the photo centers, the exposure centers, and assemble those into flight lines based on some parameters that, as a user, I can control here. I can set the minimum length of a flight line. So if I have, I have short little lines or transit lines that I don't want included, those will be excluded. I can set a turn radius as to how tight a turn I want to include at the end of my lines. For this particular workflow, when working with the Phantom 4 RTK, we recommend keeping this turn radius at 0. That'll make sure you don't drop any photo centers, any exposure centers at the ends of lines. And then we can set a deviation parameter, or basically how linear or how straight do I want to define it as a line. So if I'm doing, if I'm starting to drift off linear, how much off that linear in terms of degrees can I get and still continue as a line. So basically, if my trajectory points start to deviate more than x from a straight line, then break it up into separate lines. And that's what the deviation is here. And 10 is a good default value to use. So we'll just go ahead and click Compute Flight Lines. It'll do this automatically for us. And so you can see it's gone through, it's added a new layer into my map. So I now have a flight lines layer. Those obviously are in my map display, of course, are the blue lines. And it looks for the most part that it's performed exactly as the way that I want to. I'm interested in these straight strips. I'm not interested in my transit legs. And generally, I think those results are fine for now. So I'm going to go ahead and click Close, and we'll move on to the next step. So the next step in our workflow is to create our True View trajectories. And this is a concept that when you're new to the program, to the workflow, it can take just a little bit to get sort of set as to what we're actually doing here. So to refresh, what we've done is we've created a single trajectory that has been PPK, post-process kinematic, corrected to give us accurate positioning solution. We've also then created our flight lines, the blue lines that we're seeing here on the map, to basically show the area that we want to focus on for actually doing our the images we actually want to use to generate our ortho photo on our point cloud. So the purpose of creating our True View trajectories is to essentially combine those two, to use the flight line layer to create a reduced trajectory file from the post-process kinematic trajectory for each flight line. So we'll have then an accurate PPK trajectory for each flight line that we can then feed into our downstream workflow. Now this is an important step. We're going to just move on the toolbar to the next one step here, which is the Create True View Trajectory. So I'll click on this and bring up this dialog. And this is an important dialog, so I'm going to go through this in a little bit of detail so we can understand what's going on here. Obviously, we need to input the flight line layer. There's only one flight line layer in our project, so that it will typically default to the correct layer. Remember, if you have multiple flights in your project, multiple cycles, you can select which one that you want to work on here in these drop-down bars here, but we're still just working with the one cycle, the one flight, so that it's going to default to those. It will also tell us where the actual post-processed trajectory file is. In this case, it's just called post-processed traj.txt. And then the middle section of the dialog here is very important. This is the calibration section. So this is where we ensure that you're using the correct camera calibration file for your system. Camera calibration, of course, is critical to getting good results, good accuracy. It's not something that we have time to go into in this walkthrough, but it is a critical part of getting good, accurate results from your workflow. Now, camera calibration files and calibration files for 3DIS sensors, for the LiDAR sensors, are maintained on our Reckon web portal, and the software will automatically communicate back with that to ensure that you're always using the latest calibration file, or in certain circumstances, should you need to back up or use a previous calibration file, they're all kept on file on the Reckon site. So you have a full record of all your calibrations and what's the most recent and most accurate calibration file to use. And if you're not using that, the software will just automatically update that. You can sort of see here it's telling us that for this particular system, it's got the serial number of my Phantom 4 here. It's telling me the cycle resident calibration date. That is the date of the calibration file that's included in the workflow that we're doing is January 1st, 2019. But there was a later calibration that was done not that much later, about 2 weeks later on the 11th. And that's really the one that we want to be using because it's the more recent file. So that's the default that we'll use. Use the latest available calibration file on True View EVO. Now, if you purchased your hardware, if you purchased the Phantom 4-RTK, or of course, if you purchase one of our 3DIS sensors or one of our True View LiDAR camera sensors, the calibration files are just automatically maintained for you as part of that, that hardware. If you didn't purchase your hardware through us, you can still use the Reckon portal to track your calibrations. You'll just have to contact us. Our support team can walk you through. You have to send us the calibration file, and we can post that into the repository so you can access it through the portal. And of course, anytime you change your calibration, you would need to update us on that. We're not going to be aware of any changes if it's not hardware that you purchase through us. But as a user, it's perfectly seamless. It doesn't matter who did the calibration. As long as the calibration file is on record, you'll have access to it here. The bottom section is important for our Phantom 4 workflow because this is where we tell the software which photos we want to keep for generating our ortho photo. Because again, we may have photos that we don't want to use in the process, in the orthophoto processing or the point cloud generation processing, especially if we've got transit lines, or if we had to transit to a start or end point in our flight. There's just areas that we may not want to use those photos in our processing. So this is where we can tell the software this. Generally, the default is just retain the photos within the flight line. So any photos that are on my blue flight lines, I'm going to keep. I can also keep photos in my interior turns between flight lines, or I could just retain all of the photos. The recommended default is just keep them within your flight lines, because the purpose of defining these flight lines is to identify the area that we want to use our images from. And then finally, we have an option to go ahead and update the Exif tags on the individual photos with what we call the true pose information. So essentially the accurate position and orientation information that we now have for the system. So basically update that in the Exif tags. And we have an option to determine what the starting flight line number is if we want to play with that. So I'm going to go ahead and kick that off, and I'm going to, I'm using my latest calibration file. I'm going to retain all the photos in my flight lines, my blue lines, and I am going to update my Exif tags. So I'll go ahead and click those trajectories, and it'll run through this here. And we can see we've got a successful completion of the trajectory creation and the updating of the Exif files. Now, when we ask it to retain certain photos for further processing, it does create a new layer, as you can see here. It's created a retained photo layer. So that's the layer that will contain the photo centers that we want to use in further processing. Essentially when we come to the export photo package step. Okay, so we're finished with this step. Just a couple of cleanup notes before we move on to creating our photo package and our orthophoto and point cloud. If I had chosen not to update my Exif tags in the previous step, I can do that later. There is just a separate tool right here that will let you update the Exif tags. Very simple dialog. We'll just basically give it the photo layer, and it'll go through and update those tags for us anytime we want to call that tool. If I want to check that the Exif tags were updated correctly, and I do have the proper positioning in my photo centers, one quick way I can do that, if I select my photo layer here, I can just select it and right click, I can bring up Feature Analyst. So this is a tool within True View EVO that basically allows us to basically look at the metadata about features on a layer in our map, in this case our photo centers. And that will give me a view into the individual images and all sorts of useful metadata and tags about what's associated with that particular image. The first two columns, as you can see here, the position quality and the orientation quality, tell me what sort of solution I have on the positioning there. So I do have my PPK positioning here. If I select an image in the upper part of the Feature Analyst dialog, it'll pop that image up for me so I can visually review it, of course, but also if I right click my mouse down here in the image, I can bring up my Exif information for that particular image. And so I can review this as well, and what I'm looking for is to make sure that I've got my GeoQ specific tags in here for the updated position and orientation and camera calibration information. So that lets me verify the Exif tags were updated. The other set of tools that we won't go into, but I'll just point out for you here, is when we created our flight lines, we did so with the automatic flight line creation tool. That works quite well, especially for a regularized collection grid or a flight pattern like we have here. But there certainly are circumstances where it's not going to give you good results, or you really want to be able to go in and essentially manually create your flight lines. So we do have tools on the utility toolbar right here that'll allow you to manually create flight lines. And so often if you have a more complicated flight pattern, or you just have certain turns in your flight path that the auto generation isn't working with, you can use these manual tools to go in and structure the flight lines exactly the way that you want to. And that can be very effective. But it is there, it's relatively straightforward, and it's covered in the user guide if you do want to look that up. So the other step that I'm going to do offline here, actually, this site actually required a second flight. There's actually this section, the east edge of the site, that wasn't captured in the first flight. Now, if you're doing this as part of an online class, we're going to go through that as an exercise, but for the purposes of this walkthrough, I'm just going to go and repeat exactly what I just did and bring that flight in so we have the full flight, and then we'll move on. So there offline, I've brought in my second flight. You can see I've got a couple of extra flight lines on the east side of the field here to fill in my my site coverage. I've also got essentially a duplicate set of layers for that flight in my table of contents. I've also gone through and run the PPK positioning solution, created my flight lines and my True View trajectories, and updated my Exif files. Essentially, just repeated what I did for the first flight that we imported. So both these flights are at the same status. So I'm now ready to move on and essentially finish out my workflow. I want to generate my ortho photo on my point cloud. I'm going to do this in Agisoft's Metashape. To assist with this, True View EVO has the ability to export a photo package, to essentially package up the images, the photo centers that we're interested in, along with the appropriate calibration files and additional ancillary files for Metashape, or also for Pix4D. We support both of those, or for use in any other photogrammetric workflow in a generalized sense. So I'm going to go ahead and do that. Now, because I've got multiple flights in my project, I do have to run this step for each flight, but what the software will do is combine those into a single export package folder, essentially, that we can then use when we drive Metashape. So it's a very simple tool to use. It's this tool right here, which is the export photo package option. Just click that and it'll bring up the dialog for me. And essentially, I just have two pieces of information. I need to tell it what retained photo layer I want to use and where I want to put my exported photo package. So I can see for this particular layer, it's the essentially 658. I'm looking at the last 3 digits there just to identify it. And I simply need to go and give this a location where I want to keep my photo package. So here you'll use your own folder structure and project structure course. What I've done, as I've said, I have a master project level that I've set for my True View EVO, and I have project subfolders for each project in here, which are automatically created when I ran that import. So here's our P4-RTK irrigation site project. I'm just going to go into here and create myself a photo package folder. And tell it that's where I want to put my photo package, of course. So I'll go ahead and export that photo package from flight 658. And so it's completed that. Now I want to add my second flight to that export package, of course, and so that's just a matter of coming up in here and selecting the appropriate cycle and flight. In this case, I want to have flight 459, just looking at the last 3 digits as the designator there. And so now when I click export photo package, it's going to go ahead and say, okay, retain photo layer for flight 459, and of course we're going to put it in the same folder. And go ahead and click export. And what True View EVO will do is it recognizes that there's already a set of images in that there's already an exported photo package, and it will essentially combine them. It understands that we're basically merging these 2 separate flights into a single photo package that we can drive into Metashape. And so there we go, we're finished with that. So the final step in the workflow, of course, I want to go ahead and generate my ortho photo and my point cloud in Metashape, as I mentioned. So I'll be using this tool right here, create ortho package, create ortho from photo package. In this particular case, I'm going to be driving directly into Metashape. We're tightly integrated with Metashape, so we can directly pass the information into Metashape. With Pix4D, the photo package is still essentially set up for you. You just have to load it in from the Pix4D side. We don't have quite as nice handshaking with Pix4D as we do with Metashape. But it's relatively straightforward. If I go ahead and click this off, I get a single dialog that's going to essentially just verify the information that I'm going to pass into Metashape and then kick off the process. So of course, the photo package that I want to pass in, it'll default to the last one that I exported, so we're pointing in the right photo package folder. Verify I've got the correct coordinate systems I want to be working in. Now, obviously, the photogrammetric processing is much more time-consuming than we have time to walk through here. I am going to show you the results, but I'll run that off, and then we'll come back when we have the results. But in a production environment, you may not want to instantly kick off the photogrammetric processing. You may want to set up your Metashape project. Structure everything appropriately, but not necessarily kick off into doing the ortho photo generation and the point cloud generation. So you do have that option. In terms of generating the orthomosaic, we have two options that we can choose from. Probably the typical option, if you're just doing a Phantom 4 type of project, is you are going to use the point cloud generated from the photos. However, if you have a DEM, either from a LiDAR system, because perhaps you were flying a 3DIS system, one of our True View systems like a 515 or a 640, you have imagery and you have LiDAR elevation surface already generated at this point in your workflow, and you can pass that DEM surface in. That will save you processing time and improve the overall robustness of your photogrammetric workflow. But generally, you're just going to use the point cloud that you're getting from the images if you don't have that LiDAR data. Now, because this processing is resource intensive, it consumes time. It takes time to finish. We do have this tie into True View EVO's email notification system. As long as you've got this set up and configured, then it will automatically notify you by email when it kicks off the Metashape process, if there's any errors with that, or when the Metashape process finishes. You don't have to sit here and babysit the process as it's running. You can go on and do other tasks, and it'll let you know when it's finished. So I'm going to go ahead and kick this off here. But as I said, we'll then come back once I've got that finished result.
Okay, so we're back. We received notification. I got my email notification that my Metashape process had finished. If I go look at that, what we'll see is that in my project folder, in my photo package subfolder that I created when I exported the photo package, in addition to the original export from True View EVO, I now have a Metashape subfolder. If I go into that subfolder, I'll see my photo package, and if I drill down, I'll see all of the output from Metashape, including my ortho as a geotiff and my point cloud as a LAS file. We've also generated the QBR file, which is a support file for True View EVO, and I also have my report, my Metashape report. So I get all of the outputs that I would expect when generating an ortho photo in Metashape. I can go in here if I want to and review this report just as I would any normal processing. I've got all the detailed metrics and analytics that Metashape normally provides for me. Of course, what I want to do is go ahead and pull these new data sets, the orthophoto and the LAS file, back into my True View EVO project. And I can do that pretty easily. I'll just run the import here. We'll start by importing the orthophoto. So it's just a matter of browsing out, make sure I'm in the correct project. Yeah, this is my Phantom 4-RTK irrigation site project. And there's actually my ortho right there. So I'll go ahead and grab that. These import tools are the standard way you bring data into your project, into a True View EVO project. True View EVO, remember, is built on our core LP360 architecture. You can use it for working with any point cloud data or bring in any ortho photos. They don't have to be from a True View workflow. So it's brought that Metashape ortho photo in. It's actually below the Google backdrop, so I'll just pull it above my Google backdrop so I can see that there. And we'll turn off Google just for convenience. And I'll go ahead at the same time. I'm going to go ahead and pull in my point cloud. So this is a LAS file. It's actually in the same folder. Go ahead and grab that. Okay, so I have my last layer. Again, it's put it at the bottom in my table of contents. I'll just pull that above the raster. So I have that there as well. So at this point, we're essentially finished the Phantom 4 RTK post-process kinematic solution. We've gone through all of the steps to apply that precise positioning solution, that PPK solution. We've then driven those images into Metashape to generate our orthophoto and our point cloud. Now, of course, from here, you'd move on to doing some value-added work, whatever deliverables that your client needed, or perhaps they just needed the orthophoto and the point cloud, in which case you would be finished. So that's essentially the end-to-end workflow. So we'll wrap up here and summarize and wrap up. However, before we do that, I'll just take a quick look at the orthophoto, because of course that was the primary interest that we had in this particular site. So to do that, I'm just going to turn off all of my informational layers here, my trajectories and my photo centers and retained photos and so forth, and my flight lines. I will look at that's the labs, that's the point cloud. We can look at that as a tin surface as well. Again, True View EVO is built on our core LP360 software, so it's a standard software package for working with LiDAR data or point cloud data from photogrammetry. So fairly decent tin, but what we're really interested in, let's just zoom in a little bit on the raster itself. And of course, if you're working with Phantom 4 RTK, definitely the price performance is great on these systems in terms of the quality of ortho that you can get, assuming you've done a good data collect. It is very nice, considering the price of the system that you have. So there we can see the ortho. So let's wrap up and summarize and just go to some conclusions.